Welcome to day 3. We're going to do dilations on the coordinate plane today. You've got 2 warm-up questions. Go ahead and pause the video, give each of them a try, and then when you hit play, a box will come up for you to submit your answers. So if the perimeter is 8, scale factor is 4. Perimeter is a one-dimensional measurement, so you can just do 8 times 4. So you get that the perimeter of the other one is just 32 units. In the second one, area is units squared. So basically, each of the units has to be multiplied by 4. So you have to do 10 times 4 squared. So 4 squared is 16 times 10, you get 160 units squared. So we wanted scale factor of 3, so copy one of the angles to start out. I chose to copy angle E. And then extend the lines for angle E and mark off 3 times the distance. So 3 of the sections of EF, 3 of the sections of ED, and that tells you where your new ones are. When you copy an angle, start out with one of the segments, make an arc, set your compass to the width of the arc, put your point on here. Oops, looks like I had started actually the other way, but put your point on there, make a mark. That'll tell you where to extend the other line through. We wanted half, so I copied angle Z first off. And then to do half, you had to do the perpendicular bisector of the 2 sides of angle Z. So those are those constructions you have there. And then we're just setting our compass from Z to this midpoint, marking that off to get X prime. Z to this midpoint, marking it off to get Y prime. So they gave us the angle already, which was nice. All you had to do is extend the sides, mark off twice the distance to get G prime and F prime. So that one should have been a little bit easier. So here they gave us A prime, B prime. We needed to measure it and see how many of them fit on AB. And it was off just by a tad, but it should have been that it's a scale factor of a half roughly. So then you had to copy either angle A or B. I chose to copy angle A, extend it through, and then you had to do the perpendicular bisector of AC, measure off that length from A to this midpoint, and then mark that off. Oops, sorry, not there. Mark that off to get where C prime should be. Extend lines from O through each of your points, measure the distance, mark it off again, and then with your primes, connect the ones that were originally connected. So A to B, B to C, and C to D prime. So we'll be on page 22. We'll need compasses and straight edge to start out. So we want a dilation centered at point C with a scale factor of 2, and we're doing that of point AB. So what we want to do is with our straight edge, start at C, go through point A, and with your straight edge, start at C and go through point B. So now with your compass, measure from C to A, and then mark off that distance again. So measure from C to A, mark off that distance, and that's where A prime would be. Measure from C to B, mark off that distance again because it's scale factor 2, so we need 2 of those sections total. That's where B prime would be. And then use your straight edge to connect them. So this one we want center of our dilation is C again, scale factor of 2, and we want to do AB, but notice now that our point is on line AB, whereas last time it was not. So what we want to do is with our straight edge, we want to extend AB in both directions. And it's going to be the same principles as before. We'll put our point on C, pencil on A. So point on C, pencil on A. Mark that off again, and that'll tell you where A prime is. Put your point on C, pencil on B. And put your point on B, mark that off again, and that's where B prime is. So these two dilations that we constructed illustrate a key point that we're going to work with today. Notice in the first one, when the center of dilation is not on the original line, the dilation creates a line that is parallel to the original line. And notice when the center of dilation was on the line, the image is right on top of the other line. So that is the big idea of what we're going to work with today, but we're going to see it within coordinate geometry. So if the center of dilation is on the line, it's the same line right on top of it. If the center of dilation is not on the line when you dilate it, it's a parallel line. So let's go over to 23 and we'll get that down with the notes. So if you dilate at some center C with a scale factor of R, your A prime, B prime, that length should just be whatever R is times AB. So if you had a scale factor of 2, it should be double the length, 3, triple the length. If C is not on AB, we saw that created parallel lines. So AB is parallel to our image A prime, B prime. And if it was on it, then they were collinear. So meaning they were right on top of each other. So on the bottom, the big idea out of this, if you're to dilate a line with the center not on the line, the image and the pre-image would be parallel to one another. Whereas if you dilate it and the center is on the line, the image and the pre-image are the same line. So that is the big idea for today. Not on the line, the dilation will create a parallel line. On the line, the dilation will create the same line. So let's see this idea from a coordinate perspective. So we've got E, which is negative 1, 4. So we'll go 1 left and 4 up. And G is 2, negative 5. So using your straight edge, connect those 2 points. Now we are going to dilate centered at the origin with a scale factor of 2. So let's predict what we should notice before we even do the dilation. Notice when we drew with our straight edge, it was close, but 0, 0 is not on our original line. So if the center of dilation is not on the original line, when we dilate, we should get a parallel line. So that's what we should notice here. We should get a line that's parallel. So if you're dilating and you're at the center, you can just multiply the parts of your coordinate by the scale factor. So 2 times -1 is -2. 2 times 4 is 8. For G prime, 2 times 2 is 4. 2 times -5 is -10. And we'll go ahead and plot these now. And use your straight edge to connect them. And you should notice that they're pretty close, but they're definitely not the same line. They're parallel. Now, the reason they are so close to one another is really that center of dilation was not that far off the line. So our image is not that big a difference from the original, but it is clearly not the same line. It's a parallel line. So the big idea here is the center of dilation was not on the original line EG, so therefore E prime G prime was parallel to that original line. Going over to page 24, we want to graph y equals 2x plus 1. Well, remember mx plus b, we want to start with the y-intercept, which is the b, which is 1. So we'll put a point here on 1. And then the slope, 2, is really 2 over 1. So we're going to go up 2, because it's positive, and right 1. So keep going up 2 and right 1 over and over and over again. Oops, that point's off. And then repeat that in the other direction. And then once you have that, connect those with your straight edge. We'll put arrows on them, and we'll label our equation. So we're going to perform 3 different dilations to this original line. The first one is centered at 0, 0. So if we look at our original line, we want to notice that 0, 0 is not on that line. Now, if you didn't have the graph of it, the way you would check to see if it's on the line is you would fill in for the x and y and see if it gives you a true statement. So put 0 in for the y and 0 in for the x. 2 times 0, 0 plus 1 is 1. That's not a true statement, so that would tell us that 0, 0 is not a point on the line. So that's how you'd have to do it if you didn't have the graph. But we have the graph, so we can look and see 0, 0 is not on there. Well, we know that that should then create a parallel line. Parallel lines have the same slope. So we know we're going to have y equals 2x, and then we've just got to figure out what's going to go in for our b part. So what we do is we take one point and we dilate it. So let's take this point, maybe 0, 1. Let's dilate it. We're multiplying by 5, so this is going to become 0, 5 now. once you have that, just redo your slope. So we'll go up 2 over 1, and then we'll do the opposite, down 2 and left 1. Use your straight edge to connect those. And what we're looking for is the y-intercept. Well, notice our y-intercept is now at 5, so we're going to have 2x plus 5. If you are centered at 0, 0, and you notice 0, 0 is not on the line, you can simply get the y-intercept by multiplying the original y-intercept by your scale factor. But that is only if you are centered at 0, 0. We'll show you what to do in one of the other ones if you are not centered at 0, 0. All right, next one. Remember the one with the green arrows there is our original. We're now going to be centered at 1, 3. Well, notice 1, 3 is on our line. So therefore, we should get back the exact same line. So nothing we need to do there other than recognize it's going to be the same line. Now, if you didn't have the graph, how you would check is, again, sub in for x and y. We would have 3 equals 2 times 1 plus 1. 2 times 1 is 2, plus 1 is 3. So that gives us a true statement, so that would show that our center of dilation is on the line. Because if you don't have the graph, that's how you would have to do it. Now in C, negative 2, comma 4 is not on our original line. Negative 2, comma 4 is like right there. We would be able to tell by subbing in, if we needed to, by filling in the 4 for y, negative 2 for x. 2 times negative 2 is negative 4, plus 1 is negative 3. So that's how we, without the graph, would see that this point is not on the line. So the connection we want to make is, this means we should be parallel. So we know we're going to have y equals 2x. We just have to have the b value. So take a point on our original graph. So I'm going to take this y-intercept again of 0, 1. Notice we went left 2, or sorry, from our center of dilation, we went down 3 and right 2. So from the center of dilation, we need to do that movement twice. So that's already down 3, right 2 once. We need to again do down 3 and right 2 again. So if we go down 3 and right 2 again, that's going to give us this point here. That means we know that that point should be on our line. And now we just do our slope from there. So go up 2 over 1 a bunch of times. And then do the opposite. Use your straight edge to draw on the line. And just note where your y-intercept is. We're at negative 1, 2, 3, 4, 5, 6. So we'll have 2x minus 6 for that. So check and see if the point is on the original line. If it is, then it's just the same line. If it is not, then we need to dilate one of the points using our scale factor and then just replot with the slope, and that'll allow us to determine where that y-intercept is. So moving down to the bottom, we've got 2, 0 for I, which would be right here. And we've got negative 2, 2 for D, which would be right here. Now notice they're telling us this is a line segment, so we don't want to extend this forever. We want it to just go from I to D. Now they want us to do a scale factor of 3 from the point 1, 2. Well, 1, 2 is right here. Notice that is not on the original line, so this is going to create a parallel line. Notice to go from our center of dilation to I, we go down to right 1. We have a scale factor of 3, so we need to do that movement 3 total times. Getting to I already did it once, so we'll again go down to right 1, down to right 1. So this will now be I prime. For D, notice from our center of dilation, we went left 3. So we've got to do that 2 more times, so it's 3 times total. So there's left 3, there's left 3 again. So that's going to be our D prime. Use your straight edge to connect those. And notice it creates a segment that is parallel to our original segment. Give you a moment to read through question 6 on page 25. So when working with your scale factor, okay, which they're calling K, our fraction needs to be something involving the image in the numerator over the pre-image. Because, for example, if the pre-image had a length of 2 and the image had a length of 6, then that would tell us our scale factor is 3. We must have multiplied by 3 to get there. So the first one says Q to R, which is the image. So that's good, that's in the numerator. And that matches with N to P. So it looks like this one is good, because it's image over pre-image of a length in the image over length of the pre-image. If we go down to 2, O to Q, so here to here, so that's length in our image. The thing that should correspond to is O to N, but they have Q to N. So therefore that's going to be our one that we want. Just to show you the other ones, notice 4 was what we wanted, O to Q and O to N. And then the other one has O to R, which is the image, and then O to P, which is the pre-image. So that those ones were good. So the one that doesn't match up is 2, because we need to have them both go from that center of dilation at the origin. So center of dilation is at the origin. If the equation is not changing, then we know that the origin is on the original line. Because if your center of dilation is on the original line, then it's not changing. Well, let's look at choice 1. If we sub in 0 for y and 0 for x, does it give us back a true statement? It does not, so that means 0, 0 is not on that line. Let's try 2. Put in 0 for y and 0 for x. That does give us a true statement, meaning that the origin is on that line, and we kind of knew that because the b was 0. So therefore, that's our one that would not change. Y equals 10, that's a horizontal line at the y value of 10. X equals 6 is a vertical line at an x value of 6. So those do not go through the origin. And if we go over to 26, last one for this video, we again want it to be the same line. So we want to think, okay, it's got to be on the line. So let's check each of our points. We've got our x, we got our y. Let's sub them in, see if they work. So we're going to sub in 2 for y equals negative 3 times 2 for x plus 4. So that's 2 equals negative 6 plus 4. So that's 2 equals negative 2. That's not true. So 2, 2 is not on the line. So that would have created a parallel line, not the same line. Let's try choice 2. We're putting 2 in for y. Now we're putting negative 2 in for x. So we'll have negative 3 times negative 2 plus 4. This will be 2 equals 6 plus 4. Or in other words, 2 equals 10. That's not a true statement. So negative 2, 2 is not on our original line, meaning that would create a parallel line if that was our center of dilation. Let's try choice 3. We're putting negative 2 in for y. We're putting 2 in for x. So we've got negative 2 equals negative 6 plus 4. We've got negative 2 equals negative 2. So that means our center of dilation would be on the line, creating the same line, so we want choice 3. Now, the one other way you could do this type of problem using your calculator, you could put negative 3x plus 4 in a graphs page, and then do a control T and look at the table, and just see which of those 4 points shows up in the table. That's it for this video. Have a great rest of